Hello, welcome back. Today we are going to start with chapter 4, chemical bonding. In this chapter we have 4 subtopics: Lewis structure, molecular shape and polarity, or hybridization, intermolecular force, and also metallic bond. There are 8 objectives under the subtopic of Lewis structure, but in this video we are focused on the first 3 objectives: Lewis dot symbol, octet rules, and also the formation of ionic covalent and dative covalent bond. Let's understand what is the meaning of Lewis dot symbol. Basically, it is a symbol that will going to show us the number of valence electron, either in form of dots or the cross. In the Lewis structure, the first 4 dots are placed singly on each of the 4 sides of the chemical symbol before we pair it. Okay, so for example, why nitrogen actually have 5 valence electron, but how we going to place it? Like the statement here, first 4 dots are placed singly. That's means we are going to put up, right, bottom, down, and then we can pair it. Okay, so this is the way we write the Lewis dot symbol. Let's observe this periodic table. You will notice that there is 1 dot at the element in group 1, 2 dots at the group 2, 3 dots at group 13, and so on. So like here we'll mention, we will place the electron 1 dot at a time for 4 sides: top, right, bottom, left, which I showed in the previous slide. Then you also will notice all the elements in the same group, they always have same number of valence electron. So that's why their Lewis dot symbol is almost similar, just different in terms of the symbol of element. Based on the rules that we discussed in previous slide, so this symbol, this Lewis dot symbol for X is incorrect because they didn't put it singly. So for the Y and Z as well, okay, the electron must place 1 by 1, okay? Okay, let's continue with octet rule. What's the octet rule mentioned about? It is stated that atoms tend to gain, lose, or share electron in order to achieve the configuration for the noble gas. As we know, elements that known as noble gas are always in the group 18, at where they are always no need to share or gain or lose electron. So means that they already achieve stable. So and always end with the electron configuration Ns2 and P6. Okay, so this is the answer for tutorial question number 2. Stability of the electronic configuration for ion, okay, because mainly when the atom gain or lose electron, they will become ion. Mainly there are 4 types of stability. First one is the noble gas configuration, which always end with Ns2 and P6. While the second is the pseudo noble gas configuration, always end with Nd10. So the meaning of pseudo here is false. Okay, false noble gas means that they seems like the orbital is already full with electrons, like D10, but they are not in the octet rule. So okay, means that they are not same as the noble gas and with the 8 electrons. So that's why we know this as false noble gas configuration. The third one is half-filled d orbital. Okay, as we know, d orbital maximum can fill 10 electrons. So if half fill means that the electron configuration will always end with d5. The last one is inert pair effect, which always end with Ns2. But do keep in mind, this one normally is for the heavy metal and it is not in the syllabus. Okay, so means that you have to know these 3: noble gas configuration, pseudo noble gas configuration, and also half-filled orbital. Okay, without wasting the time, we continue with the tutorial question number 1, which the question asks us to write the electron configuration for the most stable ion, and then we determine the type of stability. Okay, so just now we already go through 3 types of stability: noble gas, pseudo-noble gas, and also half-filled d orbital electron configuration. Let's look at the first one, magnesium. Okay, before we can write the electronic configuration for ion, do always keep in mind that we always write the electron configuration for atom. So based on this electron configuration, we notice that there is 2 valence electron. In this case, magnesium tend to lose electron, become Mg2+, and end with the electron configuration with S2P6. So the type of stability is noble gas configuration. Let's continue with the B2. Okay, same case as well, we write the electron configuration for the atom, which end with 4s1. So from here, we know that this is the valence electron, and we tend to lose this electron. Okay, copper tend to lose this electron, becomes Cu+, at where it will end with D10, which we know this as pseudo-noble gas configuration. For number 3, the chromium, when we write down the electron configuration, 3d54s1. So this is the valence electron. But in this case, I think you are going to, chromium tend to lose 1 electron to achieve 1s2 up to 3p5, at where this is known as half-filled 3d orbital configuration. Last question is the oxygen. In this case, we will see that the electron configuration ends with P4, at where oxygen tend to gain 2 electrons to achieve stable octet electron arrangement, which the type of stability is known as noble gas configuration. Okay, let's look at more exercise, which also need you to write down the electron configuration and state the type of stability. So first one is the chloride ion. So with the proton number 17, gain 1 electron 18. So the electron configuration will end with 3p6. Okay, because the electron configuration ends with S2p6, so we know that the type of stability is noble gas configuration. While for the mm2+, the proton number is 25. So before form ion, the electron configuration is 1s2 up to 4s2. Then now they tend to lose 2 electrons, means they're going to lose 2 electrons from 4s orbital, so end up with the d5. So if the electron end with d5, so we know that the type of stability is half-filled d orbital. Okay, last one, proton number for sodium is 11, then tend to lose 1 electron, end up the electron configuration become S2 and P6. So again, this is the noble gas configuration. Okay, now we continue with the type of chemical bonds. Basically, we have 3 types of chemical bonds. So ionic bond and covalent bond is not new for you. You heard this during your SPM time, while dative bond or coordinate bond is a new type of bond that you're going to learn. Okay, generally the type of bond between 2 atoms will depends on their electronegativity difference. So generally, based on the 3 type of the chemical bonds, then we can find out if the difference of the electronegativity less than 0.5, we consider it as non-polar covalent bond. While if the if the electronegativity is in between 0.5 to 1.7, this covalent bond will known as polar bond. If the electronegativity is more than 1.7, then we will consider the type of bond between the 2 atoms is ionic bonds. Okay, let's take the example. Aluminium fluoride Okay, the electronegativity for fluorine is 4, and then aluminium is 1.61. So when we minus it, we will get 2.73, which is more than 1.7. So that's why aluminium fluoride is ionic compound. So now let's take the example for the aluminium chloride. Electronegativity for chlorine is 3, while aluminium still 1.61, so we get 1.39. So in this case, we know it is less than 1.7, the difference, so it is covalent bond. But if we want to more specific, is polar or non-polar covalent bond, because this one is less than, more than 0.5, so it is a polar covalent compound. Now let's continue with tutorial question number 3. For 3A1, the question asks us to define the definition for ionic bond, and then number 2, they ask us to show and explain formation using the magnesium fluoride. Okay, we do the definition first. So ionic bond is the electrostatic force between cation and also an ion that hold together in a solid crystalline. So these are the keywords to define ionic bond. Okay, second part, remind here, you need to show. When we show, normally we are going to use diagram. And then when we want to explain, normally we will use wording. Okay, so let's look at the answer. For the part of show, you have to show there is one magnesium atom with 2 valence electrons, and then 2 fluorine atoms, and each of them have 7 valence electrons. Why we need to show the atom? Because this question here is saying that formation means that you want to show before and after. So as the reactant and then become the product. So when the valence electron of the magnesium is donated to each of the fluorine, so it will become Mg2 plus, and each fluorine atom gain 1 electron will become a fluoride ion. So here total we have 2 fluoride ion. So this is the product. So when we want to do the explanation, basically like what we mentioned just now, we have to mention that magnesium will donate 2 electrons to form Mg2 plus. Okay, while the 2 fluorine atom will accept 1 electron each to form F negative fluoride ion. Then both the magnesium ion and the fluoride ion will achieve stable. Okay, because of that is why they need to very specific donate 2 and gain 1 electron. The purpose is to want to achieve stable octet electron arrangement. Then now both of them have positive and negatively charged with cation and anion, so the electrostatic force between them will be known as ionic bond. Okay, second part of the question 3b, they ask us to use the Lewis dot symbol to draw the ionic compound. Okay, so again, from the term draw here, we will have idea. We need to show like diagram. Okay, but different from the 3A2 just now, this one didn't mention about the formation. So means that we can directly give the Lewis dot symbol for the product, which is the calcium oxide. So for example, in this case, the calcium will become 2 positive, while the oxygen become oxide ion will become O2 negative. Okay, magnesium chloride Mg2 plus, and then there is 2 chloride ion. So the 2 this time will at the front here, which is showing the number of, okay, the number. Okay, how many chloride ion? 2 chloride ion. While for the aluminium fluoride, as we just now we already know, the electronegativity is more than 1.7, so they are ionic compound. Okay, so based on these 3, we can we can get a very simple conclusion that normally for the cation, after donate or lose electron, there is no valence electron already. Okay, it means that previously the valence shell contained the valence electron. Now the valence shell that we mean is the previous one have no electron. While for the N ion, the valence shell now always will contain 8 electrons. Okay, so again, if the question asks for formation, we have to show reactants and also the product. Means that you have to use the arrow to show how the ionic bond can be formed from the atom. Okay, while if the question just asks us to draw the ionic compound, we no need to show how they form from the atoms. Continue with tutorial question number 4. Define the covalent compound. This is not a new term for you. As we already know, it is always referred to the electrostatic force between the nucleus of the bonded atom with the shared electron in a molecule. Okay, for B, again, we are going to use Lewis dot symbol, and then we are going to show and also explain the formation for the fluorine molecule. So let's look at the diagram first. Okay, this time the arrow is using two, both are double-headed, which means that they are going to share the electron. Okay, so this is the redox symbol for atom, and then this one also, and the fluorine molecule is formed after the electron is shared between the two fluorine atoms. So if we want to do the explanation, we are going to use wording like in question number 3, where each of the two fluorine atoms contribute 1 electron. So from this statement, we can see that both fluorine atom has contribution. Okay, each of the two fluorine atoms contribute 1 electron, and then they are sharing to achieve stable octet. And then a fluorine molecule will be formed. Question number 4b. This time we are going to choose to draw the Lewis dot symbol for pH 3. So in this case, we can see each of the hydrogen atom going to share 1 electron with phosphorus, while phosphorus will contribute 3 electrons to share with the hydrogen to form pH 3. This is the structure. Now let's look at the explanation. Each of the 3 hydrogen atoms contribute 1 electron to achieve duplet. Okay, do keep in mind, if it is related to hydrogen atom, we're going to use the term duplet. We cannot use the term octet. Okay, if use the term octet, in this case, is considered wrong. And then continue with the phosphorus part. Phosphorus will going to contribute 3 electrons for sharing again. Why want to share 3 electrons? To achieve stable octet electron arrangement. And then end up pH 3 molecule is formed. So by seeing these two examples, we will get the idea that if it is a covalent compound, both atoms, or we can say like this question, we have 4 atoms, all atoms contribute electron. As you know, covalent compound can contain either single bond, double bond, or triple bond. Okay, if triple bond means that they're going to share 3 pair of electrons, and then double bond 2 pair of electron, while for the single bond share 1 pair of electron. And then each pair of electron will be represented by a dashed line. Okay. Now let's compare the bond length, which is this new concept for you. Okay, what is the meaning of bond length? Bond length is the distance between nucleus of two bonded atoms. Okay, so for example, we have Hi. Okay, from the nucleus of hydrogen up to nucleus of iodine. So this one we call bond length. Okay, so it is a bit different from the radius. If the radius, both the atom are the hydrogen, and then we make it become half, so it will be our radius. Okay, so basically you will get the idea. Attraction between the nuclear have two pair of shared electron, double bond, will be stronger than single bond. And then end up, double bond will have shorter bond length. Okay, so let's look at the data in the next slide. Okay, now let's compare here the bonds between carbon and carbon. If single bond, double bond, triple bond, we notice that the bond length is getting shorter. While the other way, the bond energy is getting stronger. So another pair of the example, another group example is the bond between carbon and nitrogen. No matter single, double or triple, the value is different, but the trend compared to carbon-carbon bond is the same. Triple bond have the shortest wavelength, and the bond energy for the carbon triple bond nitrogen is the strongest. So based on these two set of data and also the definition in the previous slide, then we can do the conclusion that the bond length for single bond is always the longer. Okay, the longest, while the shorter the bond length, the stronger the bond. Question 4c, define dative bond. Dative bond also can known as coordinate bond. Okay, it has the character in between the ionic bond and also the covalent bond. Okay, but generally we consider that dative bond is one type of covalent bond at where they are going to share electron. Okay, but now the electron only will be contributed by one atom. Okay, if you still remember just now in the define covalent bonds, I did mention that a covalent compound form when all the atoms contribute electron. Okay, but in this case, only one atom contribute the electron, so that can achieve stable octet electron arrangement. Let's look at the example 4C1. The question again asks us to show the formation of the dative. Okay, and this time they didn't ask us to explain, so no wording is needed. Okay, this is the structure for H2O and then H+. Okay, so as we know, H has one electron. When H plus means they already lose electron. So at this moment, H plus does not have any electron. So if H plus does not have any electron, it cannot contribute electron. So what will happen here? The electron will be contributed by the H2O to the H plus. End up, we will have this type of arrow in the product H3O plus. This is showing that one of the lone pair here is already contributed by the oxygen atom and share with the H plus. So now the whole molecule is going to have positive 1. Let's continue with 4b. This time we are going to show the formation of AlCl4 negative. This time when we look at here, aluminium, okay, AlCl3, this is the structure for AlCl3, and then we notice that the aluminium only have 6 electrons. Okay, normally we supposedly going to have 8 electrons. Okay, chlorine have 7 valence electron, but here is negatively charged, means that they already gain 1 electron. So now this chloride ion has 8 electron, and then one pair of the electron for the chloride ion can be contributed and shared with the aluminium, so that end up aluminium also have 2, 4, 6 and 8 electron. Okay, So this is the formation for the AlCl4 negative. So again, based on this true example, we already noticed that for the dative bond, the sharing electron only will be contributed by one atom. And then this atom generally always consists of lone pair electron. Okay, like this one, we consider lone pair electron. While the electron in the bonds, we are known as bonding pair electron. Let's look at another question here, number 3, BF3 and NH3. So we try to draw out the structure for the BF3 and NH3 first. At this context, we can see boron have 1, 2, 4, 6, 6 electron, while nitrogen have 2, 4, 6, 8. 1 is lone pair electron. Okay, and then this time this lone pair electron will going to contribute by the nitrogen and share with boron. So the arrow will pointed from nitrogen to boron. End up this is the product form. Arrow from the nitrogen bond pointed to boron. Last example for the compound which consists of dative covalent bond. So in this case now, we need 1 mole of beryllium chloride and then 2 mole of ammonia. So we look at here, beryllium only have 4 electrons and then ammonia have 8. For the nitrogen in the ammonia have 8 electrons. So each of them have the lone pair electron. So they will donate to the beryllium 1 pair. If only 1 pair donated, the beryllium now only consists of 6 electrons. Haven't achieved octet yet. So another lone pair electron from the ammonia will be shared with the beryllium and then end up now the beryllium have 8 electrons like this. Okay, 2 from initial bonded with the chlorine and then another 2 pair are contributed by nitrogen only. Okay, and also share with the beryllium. Beryllium has no electron to be contributed. Okay, continue with tutorial question number 5. Let's say we are already given Lewis structure and then now we want to identify type of bonds, okay, present in each of the compound. So recall back what are the type of bond. First, we have ionic bond, we have covalent bond, and we also have dative covalent bond. Okay, we have 3 types of bond. Okay, so based on the Lewis dot symbol given here, it is very obvious. We see there is 3 plus and negative charge here. So at here, there is ionic bond. Okay, so I label with 1. Okay, in between sodium plus and also CO3, 2 negative here, positive and negative, we also have ionic bond. While the electron is sharing between carbon and oxygen, this one we known as covalent single bond, and this one also sharing electron, covalent double bond. Okay, same case happen at here as well. The attraction between Mg2 plus and also PO4 3 negative is known as ionic bond. The bonding between phosphorus and oxygen here is covalent single, covalent single, covalent single. And the last bond here, phosphorus with the oxygen, is considered covalent double bond. Continue with structure 4 and structure 5 again. If I label 1 nearby means it is ionic bond. And if label 2 means covalent, while label 3 means it is a dative covalent bond. Okay, so in this case, again, we can see positive charge and negative charge over here. So the bonding between here is considered ionic bond. The nitrogen and hydrogen without any arrow means that atom contribute the electron, so they are covalent bond. While the bonds between nitrogen and hydrogen, from here we see that the arrow is from nitrogen to the hydrogen, means that the electron only contribute by one of the atom, which is nitrogen, so we consider this one as the dative covalent bond. Okay, last structure, AlCl3. So all these are sharing electron, and then we didn't see any arrow, so all these are covalent bond. Thank you for staying up to here. So in this video, we are not going to show you the final answer as there is no calculation. So next video, we are going to learn about how to draw the Lewis structure. See you.